Right, the sooner we start, the sooner we finish.
Right, true.
All right, so we'll bounce around a little bit today, and I'll go back and look at the book, so I might go in a little bit different order. But let's talk about memory. When we talk about a computer and how much memory a computer has, what are we talking about? What are some different reasonable answers for how much memory a computer has? Like how much memory does your computer have?
16 gig.
16 gig. All right. Could you give me any other answers for that?
8 gig.
So when I said memory, you immediately gave me your amount of RAM, correct? Random access memory. Would giving me the size of your hard drive have been a potentially accurate answer there as well?
Yeah.
Okay, but typically when we talk about memory, somebody says how much memory does your machine have? We're talking about the amount of RAM that's in it. Okay, so 16 gig, 8 gig, these are all kind of common terms. Now, do you know the technology behind your? So you have 16 gigs. What kind of RAM is it?
I think it's DDR3.
DDR3. Okay. So pretty modern RAM, right? In fact, actually, that's the quickest. That's for system RAM. There's a DDR4 that's currently, I think, it's on graphics cards, but regardless, DDR4 is on. Oh, a DDR4. Okay, but regardless, when we talk about memory, generically speaking, what is memory? What is RAM? When I talk about memory, what is that?
Basically, to store the data for summary or
Something to store something.
Okay, something to store something. Well, there's a lot of things that fall into that category in our computers, right? So, we have our, let's kind of go in the order of speed. So we have a floppy disk, right? Some of you maybe never have seen one of those or touched one of those, but it's a thing, right? You had the really, really floppy disk, the 5 1/4 inch ones. Then you had the 3 1/2 inch floppies. Actually, before the 5 1/4 inch ones, you had even bigger ones. You ever seen one of the giant floppy disks?
Yeah.
Okay, so those guys would have been, we'll just generically say floppy disk. We would have called this. We're going to order these from slowest to fastest. We'll leave some holes in there, but slow, right? Floppy disk, very, very slow. After we go past that, maybe we're talking about like CD-ROMs.
Was a zip drive in between them?
Probably. No. Zip drives were really interesting, actually. So it would be fair to say zip drive. Do you remember? So who was the company that came out with the zip drive?
I don't know. I just remember growing up. And
Would you remember the company if I said it?
Maybe.
The company's name was iOmega.
Yes, that's right.
All right. Well, I know it's right. I wouldn't have said it. Okay, they actually had another product. It wasn't just the zip drive. What else did they have? The zip drive. What size were the zip disks?
Shoot. I don't remember. I haven't looked at one of those things in so long.
So, well, let's go with the order here. What size was a floppy disk? 1.44 megabytes. For our most recent floppy disk, those are 3 1/2 inch. All right. Then you had the zip. The zip drive started off as 100 megabytes. Okay. Now keep in mind that during a time when you're used to having floppy disks that could only hold 1.44 megabytes, 100 megabytes is huge, right? Okay, that's a huge amount of memory. Now we don't think of 100 megabytes today as being anything. Like that doesn't even seem like a viable resource for us. If somebody handed you a 100 megabyte USB stick, would you even take it?
No.
I mean, that is a useless USB stick. You probably even view like a 2 gigabyte USB stick as mostly useless.
Put it on the music.
Yeah. Okay, so the zip drives, these kind of look like floppies, but they were a lot faster. So they were faster than a floppy, had a lot more capacity than a floppy. They came in 100 megabytes and later 250 megabytes. All right, and they actually had another technology along with that. So iOmega had another product. Remember what that one was called? None of you remember iOmega? You don't remember when you were negative 3 or 4 years old? They had a Jazz drive. You don't remember that one? Oh man, let's look at this. iOmega Jazz. Look at that guy. Boom. Okay, Jazz drives were 1 gigabyte disks. Ridiculous. You can still order these? Oh, this is the Zip 250. Man, that was awesome. Remember how now these were the externals. They had internal ones too. Externally, how do they connect to your computer? What port did they use in your computer?
Print support.
So let's back up here. Might as well talk about that side of architecture then. Printer port is actually correct, but what port is that? All right, so let's talk about computer ports. All right, so I heard so you said SATA. All right, so we'll put that out there, SATA. We'll talk about what these guys, these different guys are. So we have SATA. What other ports do we have? We have printer port. You have a better. Today, what kind of port do you plug a printer into? USB, right? All right. Before USB, what kind of port would you plug a printer into? Parallel port. Okay, we heard of that before? Parallel port's about that wide, two dots tall, kind of looks almost like a VGA, like a really wide VGA port. All right, so that's a parallel port. We also have what, serial ports? What's the difference between a parallel port and a serial port other than the physical appearance? Serial ports looked a lot like a VGA port. They just were male. Well, no, they were female instead of male at the computer.
Are there more pins in a parallel port?
There were. So that's the physical aspect of it. So other than the physical aspect of parallel versus serial, what was the difference between these ports? Their names. Well, the names actually give us the answer. The name itself gives us the answer. Okay. When we talk about parallel, sending data in parallel versus sending data serially, what's that mean? What is parallel data? Because today we're going to be talking about speed. We're going to mostly be talking about speed of memory. But since these other things came up, the book doesn't actually cover this, so let's go ahead and throw it in. Okay, so when we talk about types of, I'm just going to say data communication, or maybe data transfer. It's called data transfer. That's going to be the better way of putting this. So generically speaking, we can transfer data in parallel. We can also transfer data in serial. What's the difference? If I send data serially, let's start with that. What does that mean?
One after other.
One after another. So we'll just say 1 bit at a time. One after another. Something along those lines. That's a serial connection. So now, conversely, parallel must mean more than 1 bit at a time. Okay, more than 1 bit at a time. All right, now just generically speaking, when we talk about, let's kind of generically talk about speed. Which do you think of these, which of these do you think is faster? And that's kind of it's a trick question. First, you think serial's faster?
Parallel, you have more, you can transfer more, but it's not as fast.
Okay. So, like I said, it's kind of a trick question to ask which is faster because it depends on what year you're asking that question.
Yeah.
Right? And what's the most recent technology that's come out that's using it. Generally speaking, though, when we talk about parallel, the speed is bursty. Okay? It can go very, very, very fast, but it could also slow way down because you're sending stuff in these chunks, and sometimes things can get backed up, or sometimes you don't have enough data to send to the next chunk. So you're not being efficient with the next send. So parallel, the speed is considered to be bursty. Serial speed is considered fixed is not actually accurate, but it's called consistent. There will be fluctuation, but it's significantly more consistent. You could rely upon it. And we'll talk about some different applications that use this as well. Okay, so that's the idea of parallel versus serial. Now, do you think these are still the same kind of data transfer as we use today? It absolutely is. The ports look different, but still the same thing we use. So parallel used to come across on what was called a parallel port. So let's look at a parallel port. This was the port you would plug your printer into. So it would look like this guy right here. That's a parallel port. And here's serial ports underneath here. See the shorter serial ports? Here's another parallel port. Here's a pink parallel port. It's for Sheikah. Well, she's the designer, it seems like, right? She's one of these pretty interfaces. Who cares if it works? Just so as long as it looks good, it's fine. All right. So yeah. So here's some examples. So this is a parallel port. This is a serial port. This is a VGA port. See how the serial and VGA look very similar, except the VGA port is the, I guess depending on how you look at it, this is the male component, this is the female port. All right, so, but they look very similar, but they're different cables. And you can actually see they do have a different number. So there's 3 rows of holes here, pins, and there's only 2 rows of pins here. So don't try to shove a parallel cable into a well, it would be a parallel extension cable is what would end up being into a serial port. You'll bend the pins is what will happen. Then you got to get the needle nose pliers out and straighten the pins and hope for the best. All right. So in any case, those are what parallel ports used to look like. All right. So this is what a parallel this is what a parallel cable used to look like. I have a feeling that it would have looked better. I'm going to get a good picture. Okay, so this is what would plug into the, perfect, thank you. This is what would have plugged into the back of your computer, and this plugged into the printer. So this is specifically a printer cable. So the back of our printers used to have this beast of a connection. All right, now the back of our printers have what? The USB, kind of the square portion of the USB. Okay, that connector.
Wireless.
Oh, or wireless. Some of them use wireless now. All right, so historically, a printer cable would use parallel. A modem cable would use serial. That makes sense? Now, for a second, what's a modem? This is the internet thingy? All right, so when we used to have dial-up internet, we used a dial-up modem, right? So here, let's the 56K modem. Who was the famous modem maker back then? Come on, people, you're showing your age. If you were to buy a modem when dial-up was cool, whose modem would you buy? Netgear wasn't a company.
Cisco.
They were probably a company, but no, you buy U.S. Robotics. U.S. Robotics. Let's go to images here. This is when they were here. Look at that. U.S. Robotics fact mode. They were. Oh yeah. Oh, this is the guy.
What?
That's a U.S. Robotics 56K modem. You get all the little lights in the front here. You had the phone cord plugged into the back. You had a serial cable coming out of the sky that would plug into your computer. Oh, man. I mean, you felt like you were using the internet. Okay, so this was an external 56K modem. Then you had internal ones. How did internal 56K modems plug into your computer? What kind of port was inside your computer for that to plug into? You can take a guess. What ports are on our motherboards now? You don't even know the name of the port. You just built a computer. You just know it was the port you shoved stuff onto.
Pretty much.
Okay, well, the ports you shove stuff onto are called PCI Express ports.
Okay.
All right. So historically, we had ports called PCI ports. Now, what was older than PCI ports? None of you guys are getting hired at the computing museum. All right, so this is inside the computer on the motherboard. So a PCI port would be a white port on the motherboard. Yeah, it looks like this guy. That's a PCI port. These are PCI ports. What are these guys? Oh, actually, those are RAM ports. Sorry. That's actually not what I wanted to show you, but I'm going to do a search here. Old motherboard. Okay, yeah. There we go. What are these guys? This is a motherboard that has 0 PCI ports on it. This is before PCI. These are called ISA ports. Okay, so our early computers had these kind of ports on them. Slower. All right. More just history stuff, not that important for what we're talking about today. All right, so we had our 56K modems or our 33.6 modems or our 28.8 modem. Let's talk about that for a second because we're talking about speed and we're talking about ports today. So let's just throw in modems here. So I'll just go back to kind of an early modem. We had a 300 baud modem. Then I'll jump ahead and we're going to see we had a 4800 baud, 9600 baud, then a 14400 baud or a 14.4 kilobit per second modem. Then we had a 28.8 or 28,800 baud, so 28.8 kilobit per second modem. Anybody know what came after that? It was, the next one, well, 2 later would be 56 kilobits per second. What came in the middle here? Some of you at least had dial-up during your lifetime, right? At some point in your life, you've had dial-up, correct? You don't know what you just heard the beeps and said, I'm on the internet? Just like this guy building his computer last week, doesn't even know what ports he's plugging stuff into? Well, it's the only port it fit in.
We're trying all the other ones.
I maybe do believe you. All right, so this was a 33.6 kilobit per second modem. Now, let's add another vocabulary term here. I'm going to say synchronous. Okay, can I do multiples at once? Oh, yeah, nailed it. And then I'm going to say asynchronous. What does synchronous and asynchronous mean?
Something will.
As it relates to speed.
Synchronous is the task or whatever it waits for the. In the threading, we say that synchronous.
Yeah. So you're thinking about synchronized functions for threads. I'm talking about as it relates to how data is transferred. Data that is transferred synchronously versus data that is transferred asynchronously. Synchronously transferred data means same speed, upload and download, or up and down. Same speed both directions. Asynchronous means different speed, upload and download. We go even a little bit before that. Do transfer mechanisms. Half duplex. Full duplex. We heard these phrases before? What do they mean? Or transfer mechanisms? Yeah, so my title here. This is my title. All right, so I'll give you that one. So now, what does half duplex mean? Yeah, at a time. So half duplex is only one direction at a time. Full duplex is both directions at the same time. Okay? Now, most of our connectivity stuff today is all full duplex, right? If it's not, it's on purpose for a reason. You know, it's not that we don't have the technology to handle it. It might be more of like a walkie-talkie type thing, where you push the button when you're talking and now you can't receive anything while you have the button pushed. You know, that kind of thing. Okay, so all of these modems were synchronous. And this modem was asynchronous. Now, we've talked about, I think we mentioned handshaking in here, right? Did we not mention handshaking? I don't want to get too much into network stuff, but it's kind of related to what we're talking about here. So we've all heard when you use a dial-up modem and it starts connecting, what does it sound like? No, it's not just beep beep. You can do a better job than that. You're getting there. It's better than beep beep. All right. Same thing. Fax machines use modems, right? Okay. So all that beeping and buzzing did they just make that sound to make it sound cool? Like, well, that sounds like something techie's happening. Yeah, it could have just been a single beep, but no, they had to make it sound like that. What's happening? What's all that beeping all about? I just mentioned this phrase handshaking, right?
Like verifying the connection.
Okay, I like that. But now you've committed yourself. Okay, so handshaking, you've mentioned this is verifying the connection. All right, that would be a general definition of handshaking. Now, when we talk about a modem dialing in, who does the modem connect to? Who's it beeping with? An internet service, or what at that internet service? So if I have a dial-up modem, I have that US robotics thing. I got my phone line plugged into the back of it. Okay, I'm doing my dial-up, so it dials some phone number. What's on the other end that's picking up the phone? Another modem. Modems talk to modems, right? Modems stand for modulator, demodulator. Networking thing, not important for us. All right? So that's all about how do we get, now, why do we need a modem? What's the purpose of a modem? So this is more of an architecture thing. It's a digital thing, right? Computers are digital. Phone lines are analog. Phone lines are analog. Okay? So we're sending now our computer expects digital. So that modem's going to send us digital over our serial port. Okay? But that modem's going to be sending our requests for websites and crap like that over the telephone line in analog. So the job of a modem is to convert between digital and analog. That's what that guy does. Okay? So from our perspective, what we really care about is what happens at the computer end, right? Telephone line, important stuff, but networking concept, right? Okay, so we're not going to talk more about that, but we are going to talk about a little more networking concept, but that's also not that important, just not important for us. But we're talking about that handshaking thing, all that beeping. And you said that they're verifying the connection. What does that mean back then to verify a connection?
Well, if it's using the different tones or something, is it like almost like a passcode or a key or an address to what it's connecting to?
Oh, see, now we're going back even farther. Man. Have you? Now we're going back to like the payphones, where you can have there's like a whistle that came in the Cracker Jack boxes that you could use to blow it to get free phone calls because it operated on tones. When you put a quarter in, you heard a certain beep. So it was tones that dictated how much money you put in. Yeah, these tones, if you listen to your modem connect 3 times in a row, you might hear very different beeps. Okay? Handshaking is not always the same, so it's not a tone-based thing. Okay, think of it more as like a cat fight. All right, so what's happening here is the two modems are cat fighting each other, and you hear all those noises, and they are verifying the connection. I'm good with you up to there. Why do they have to verify the connection? What does it mean to verify the connection?
Make sure you know who you're talking to.
Okay, that is happening, but that doesn't happen until after all the beeping.
Oh.
When one modem talks to another modem, they have to figure out how fast can they communicate with each other without screwing up. That make sense? So, I mean, and we do the same thing in real life, correct? I mean, Van's English is pretty good. He understands English pretty well. So I can speak to Van pretty quickly, but some other folks who maybe English isn't as strong from an understanding, his spoken English is worse, but his understanding is pretty good. But if I'm speaking to somebody who's, maybe very weak in English, I have to slow way down. Otherwise, we're going to be introducing a lot of errors into our communication, correct? Okay, same thing. Let's flip it around. I go to someplace in Mexico, and you got some Mexican guy speaking Spanish at a mile a minute, right? Okay. I had a class in Spanish. I know some Spanish, but I can't understand a person speaking native Spanish. It sounds like they're going turbo to me. Okay. Same thing when I hear Edwin sitting there talking to, one of his buddies using his language. It sounds like they're going a million miles an hour. But maybe you think I sound like I'm going a million miles an hour. See what I'm saying? So whenever you're talking to somebody else and we are picking a protocol that we're speaking, we have to kind of figure out what is the speed, the cadence that we can send sounds back and forth so that we're not screwing up. Now in real life, are screw-ups okay? If I say something too fast, you didn't quite get it, what do you do? Yeah. Like, what, like, huh? Okay. Or probably Van's first semester, he didn't even know he didn't get it. Just sat there, he's like, why do I bother? He's not going to know what I'm asking. No, he shared this with me. Yeah, I mean, because him and I had a conversation the other day because I've been having some struggles with some other students who are missing content in a freshman class. And I wanted to understand from their perspective what their experience is. Because like, I'm speaking English. I announced this in class 15 times. Why did you miss it? If you're missing something 15 times, we are not connection. We have not successfully handshaked. Okay, there is an issue there. All right, so it helped me understand their perspective there. But the point is that when two modems are talking, they have to figure out what is the fastest speed we can talk to each other without screwing up. Now, humans do the same thing, but if we're a little bit off, it's not the end of the world because you can ask me to repeat myself, right? Okay, so you asking me to repeat myself in the networking world is called what? Okay, well, it is a retry, but there's a protocol that governs asking somebody to resend some data. It's called TCP/IP. Okay, we've seen TCP/IP before. Okay, so that whole TCP/IP thing that we just seen a zillion times, didn't even know what the heck that thing was. Okay, that's a very, very, very important thing in today's how the internet works today. Extremely important, because guess what we did not have when dial-up modems were talking to each other? We didn't have that. Okay, we didn't have TCP/IP. We didn't have the ability to say, "Excuse me, can you repeat that?" Make sense? So those two modems, all that beeping was about, look, you and I, we need to figure out how fast can we reliably go without ever messing up.
Does that have to go down to like the different types of modems that we're trying to communicate with each
Well, to an extent, because if you had a 56K modem talking to a 300 baud modem, fastest you're connecting is going to be the slower of the two modems.
Right. So I'm saying, like, if you had two 300 baud modems, would the handshaking process happen faster?
Well, 300 slower. 300 baud modem
I'm
is
just
yeah,
saying, like,
it would not happen any faster.
Okay.
Those two modems are figuring out. Almost always, your connection would be less than what your modem was capable of.
Okay.
Yeah.
Gotcha.
So if you had two 56K modems talking to each other and you had a pretty clean, not too much static on the line between the two of you, maybe you connect at like 48,000,
Okay.
something like that. They're negotiating that speed where they can reliably talk to each other and not screw up. It would be really rare to get a 56K connection. 53K, I've seen those. I've probably seen a 56K connection before, but it might have even been Microsoft magic. Kind of like Apple seems to give you an extra bar on your cell phone just because. The guy sitting there with an Android phone has 3 bar or has 1 bar. You have 2 on your iPhone, and neither of you can make a call. It's all just visuals, smoke and mirrors, right? Yeah. So in any case, we didn't have TCP/IP back then. So those two pieces of equipment had to figure out how fast could we talk to each other and not mess up. Today we have TCP/IP. So we'll just send data as fast as we possibly can and just let the protocol fix our mess ups. So when do we notice that we have real mess ups? Well, when you have to continually fix it. Okay, so in that situation where I'm speaking English to somebody who does not understand English, they're not familiar with the vocabulary at all. It doesn't matter how many times I repeat myself, they're not going to get it. Correct? So then you have data corruption, garbage in, garbage out type thing. So in a network situation, it's when somebody drops a magnet on the onto the Ethernet cable. Not a whole lot of stuff's going to get through there. They're going to always be asking for resends. It's never going to arrive. Right? That makes sense? All right. So that's the whole purpose of the handshaking stuff. Relatively unimportant for us from the networking side of things. Okay, but from our perspective, thinking about the inside of a computer when we have two components that need to talk to each other and how fast they can send data between each other, that's an important concept. All right, because we have to get these guys to line up, synchronize their speeds somehow. Okay, like we just mentioned a few minutes, it's easy to talk about from the internet perspective because those are speeds that we're kind of used to. They're a little bit closer to kind of speeds that humans can kind of relate to than, 4 zillion bits per second type stuff. All right, so in modems, we're even slower. So if we kind of go back to this thing I had up here with modems, so when I say baud, a baud modem, that's bits per second. So baud, 1 baud is 1 bit per second. So 300 baud means 300 bits per second. So if we think about our fast internet at home today, so if you, we've done this math before. If you have a 100 megabit per second internet connection, is pretty common now. A lot of people have a 100 megabit connection. How many megabytes per second is that? 12.5? Theoretical maximum, right? Assuming who you're downloading from can serve it to you at that speed, blah, blah, blah. So 12.5 megabytes per second. How many megabytes per second is a 300 baud modem? So that means it can download at 300 bits per second. So divided by 8, that gives me 37.5 bytes per second. Divided by 1024 gets me kilobytes per second. Divided by 1024 gets me megabytes per second. Not very fast. Right? Not very fast. Now, back in the days of 56K modem, I mean, I think if you remember the picture we just showed, the USB had a little flame on it. Because it's supposed to go fast. So fast that it had fire. That's how fast 56K was. So 56 kilobits per second is 56 divided by 8 kilobytes per second, so 7K a second, divided by 1024 divided by 1024. I'm sorry, no, just 1024. that is the speed in megabytes per second. Still really, really, really slow. Okay, but we're talking synchronous versus asynchronous here. Okay, and we want to think about in the context of our resources inside of our computers talking to each other. We'll kind of roll to that here in a second. But synchronous, same speed up and down. Asynchronous, different speed up and down. Now, when you have a 100 megabit per second internet connection at your house, is that synchronous or asynchronous? Asynchronous? Okay. Now, when you paid for it, when you bought it, you didn't necessarily know that, right? That's not something that they don't sell it to you. You say, oh yeah, it's a 100 megabit per second asynchronous connection. Okay. I mean, this guy has enough trouble knowing what ports he's plugging stuff into. That's in one ear, out the other. Is the deal? All right. Now, why are our consumer internet connections asynchronous? Okay, so we have upload and download. It's full duplex, right? Stuff coming both directions. All right. Typically, an asynchronous connection, as it relates to an internet connection, is faster coming down, slower going up. That make sense? Okay. So typically, you're going to be able to download at 100 megabit per second, and maybe the complementary upload to that might be 5 megabit per second, 12 megabit per second. Let's just use 5 as our example. So your upload is 5. What kind of things do you use your upload for? Okay. Very, very less. I learned that from Shiva. Yeah, so a lot of Indian, my experience has been with Indian people talking to them, they use the phrase very less. And what he means is not very often, right? But it always just sounds weird to, but I've learned that now. So now I've started using it with people too, just to get the looks.
Look cool.
Yeah, it's something. It's look cool. Sometimes I throw a couple of pops in there. One of these days, it might take me a while. I have an app on my phone. I'm trying to learn, I think it's Hindi. I doubt I'll ever learn it. Yeah, I'm trying to. I got like 4 words, but I forget them after I haven't done it in like 4 days. It's terrible.
You're not going to be remembered.
Well, I'm old, first of all. That's one. But wouldn't that be awesome if I came in and just started teaching a class in Hindi?
I'd be pissed.
But it would still be funny.
It is you paying. That time I'm going to be pretend like I understand.
I'm sorry, you wouldn't know.
Well, it's better than my Hindi now. I just make up words. I say what I say. I'm fluent in Urdu, I say, and I'm fluent in Telugu. Not fluent in Tamil. My Tamil's shaky.
Klingon.
I'm not fluent in Klingon, though, but I appreciate the dialect. All right. So we use our upload very less. Okay, we don't use our upload for a lot of stuff. We use it for, like you said, uploading pictures to Facebook, that kind of stuff, making attachments on emails, right? When you're uploading a Word document or something like that. Now, we also use it, very less for when we're like making a request. When we say, give me www.google.com, that is using our upload to make that request. And then our download downloads the website after all the internet networking stuff happens. Okay, not important for our world.
But the one thing that I'm mentioned here a long time ago, when you use a computer, you're searching on Google, you say, oh, it's fast, oh, it's internet, this is my life.
This is all text.
It's all text, but now compared to at the moment right now of a computer, it's fast. We can see that, but we don't mention about fast. We don't see it fast.
No, what we notice speed now, we're not impressed with how long a website takes to load anymore. Yeah, what we care about is like how fast are we downloading a movie, or if we have a 2 gigabyte file we're downloading, how long is it going to take? We're patching a video game, those kind of things. Yeah, that when we see the number, it's almost like miles per hour in your car. That type of thing. So we're not using our upload for very much. Now, Why do you think the upload is so much smaller so much slower than the download? So I gave that example of 100 megabit down, 5 megabit up. That's probably pretty close to the truth. It might be 10 megabit up, but let's just use the 5. It's a lot slower than the download speed. Why?
You don't need it as much.
Okay, you certainly don't need it as much. The stuff you're uploading is very less, right? The stuff you're uploading is very less.
Yeah, because the problem is you need the information as fast as you can. So that's why you need the download.
That's the download. So I think we could all agree that the reason the download speed is fast makes sense, right? Yeah, that's how we digest the information. We want our Netflix or whatever it is. We want that to be fast. No argument there. We want it to be faster. 100, why 100? Why not 1,000? Or 1,000,000? Just keep going. We'll never be happy. Okay. But 5 up is probably enough. We need it less. That's one thing. What do you think that your internet provider doesn't want you doing?
Well, could it also be like overloading the servers or something like that?
Say this again?
Because I mean, if everybody has a lot more upload, now the servers can be more quickly overload, or
Well, depends.
because then
You use the keyword server. That's the right word. You used it on the wrong side. Okay? Because my upload, if you're connected to my computer, my upload is your download. Okay? So if you are downloading a file from my computer, and you can download it at 100, and I can only serve it to you at 5, you can only download it at 5.
That's how the company gets it. Yeah.
Well, it's not how they get you. They don't want a consumer internet connection to be able to run servers from your house.
Oh, okay.
Where you are, I mean, it's okay to upload some files or something like that, but they don't want you to be able to take advantage of, basically having a consumer internet connection and you're running the next Amazon off of it from your house.
Okay.
Yeah.
I got you.
So and that's where it becomes very interesting. I mean, if you've been a user of some of these, and I'm going off on a networking tangent, but that's okay, whatever. If you've used tools like BitTorrent, so most of us in here at some point have used BitTorrent, you might say, well, I have 100 megabit per second internet connection. Why is my maximum upload so much less than that? Okay. Because even if you max out your BitTorrent, your upload will max out at 5 megabits per second. Because that's all you have. That makes sense?
Yeah.
Otherwise, if you had a synchronous connection that was 100 megabits, you can download it 100 and you can upload it 100. Cool. People on the BitTorrent network will love you. Okay? That's why the BitTorrent network loves college campuses. Because your internet connection in your dorms is synchronous. Ethernet is a synchronous technology.
Now you can sign up for.
No, but so what do? So here on campus, your BitTorrent doesn't perform that well, right? Because BitTorrent is a known protocol. So what do they do here on campus? They throttle it. I don't think they completely block it because there's plenty of, when we hear the phrase BitTorrent, we kind of have a negative connotation with that, right? We kind of think of it as that's how you steal stuff. Okay, right? But that's not true. BitTorrent itself is a networking technology that's actually widely used for disseminating like software updates, things like that, to take the burden off a single server and spread it across lots and lots and lots of clients, lots of peers who have parts of that file. Does that make sense? So it's a great technology. I mean, so BitTorrent itself, that idea of saying instead of 4,000 people downloading the one file from you, we're going to let those 4,000 people start downloading it, and then they're going to start sharing it with everybody else. So the pool of downloads, what is
Completely blocked.
BitTorrent comes with the French thing.
Oh, if you go to the website for BitTorrent?
Yeah, it's completely blocked.
All right, but I think the protocol for BitTorrent works here on campus. Otherwise, like a lot of I think Microsoft Update probably uses BitTorrent or a very related technology for doing updates. So yeah, so it's possible they don't want you to go to the site directly because it certainly does have that connotation, but the underlying technology is.
So these other ones, like other torrents that come up.
Well, BitTorrent is the name of a technology.
Okay, so that's the name of the technology.
Yeah.
These
So
other
the things you're talking about, the clients like MuTorrent,
Yeah.
that is a piece of software that is BitTorrent compliant.
Gotcha.
Yeah. But yeah, in any case, campuses have to be very careful about BitTorrent because if you have, first of all, even though there's plenty of legitimate uses for BitTorrent, there's plenty of illegitimate uses for it, right? So, and college students have been known to, not have a whole lot of money, but still want to have a lot of music, still have a lot of movies. So out of desperation and out of some shady ethical whatever, they rely on theft and steal their music. Borrow. Whatever makes you feel, whatever makes you sleep at night. Whatever you got to say to yourself. But the point is that on a college campus, if you assume you have a lot of people partaking in that type of thing, all of a sudden you can actually really hurt the whole network performance because you're taking over their upload.
Well, the thing is,
you got 500 students that are all uploading at the school's maximum speed.
My question is, okay, and you maybe explain this. Why do they need to upload so much? Like if I'm saying
at the end, okay. Well, let's just presume you've used BitTorrent before.
Okay.
So when you finish downloading a file, then your file starts seeding, right? Turns green and says that it's now seeding, and most BitTorrent users just cancel the file then, right? I got what I need. I got what I need. When it's seeding, you're uploading because what are you now? You are a potential server of those files to other people.
Okay, so essentially, whenever you download BitTorrent, people can take it from you now.
Correct. You are participating in that network. Okay, so you're not only a recipient, but you're also a server. And typically, there's a ratio. So the more you serve, the faster you can get. Okay. So that's your incentive for also sharing, is you'll get your file better or get your file faster. But then the network is reliant on people seeding the file afterwards. So their hope would be after you have your complete file, you still continue to seed. So now you're not downloading it at all, but you are a server for bits to other people that are interested in it. All right. But again, so this comes back to the synchronous versus asynchronous communication type thing, which is the part we're more interested in. We're just talking about real life examples of this, where it's very easy to take advantage of synchronous connections with today's technology. So here on campus, whether they're blocking BitTorrent, I mean, it seems like they're blocking the website, but I doubt they're blocking the protocol itself. But they certainly would throttle the protocol, at least during certain hours. So you might find that if you're, doing BitTorrent at 3 in the morning or 4 in the morning, you might find that you have some pretty good speeds, or maybe on the weekends, something like that. But on a Tuesday at 3 p.m., you probably find that BitTorrent crawls. Doesn't do very much because we're going to throttle that down so that you can't take over the upload. Make sense? All right. So this difference between synchronous and asynchronous, and I'm kind of showing it here on our modem stuff. So up to 33.6 modems, these were synchronous connections. So this guy was 33.6 down and 33.6 up. Theoretical maximum. Pending handshake. Pending that they can agree on that speed as the fastest speed they can communicate. And when two modems are talking, the fastest you can possibly communicate is going to be the slower of the two modems.
I know one that they blocked the BitTorrent.
What is that?
The upload speed is 73 megabytes.
My upload speed's way higher than my download speed.
That's good. The download speed right now, people use download more. You mentioned it. Upload very less. Right? Okay. So because of that, there's more available bandwidth for the up.
Okay. But if I were to max it out, looking across the campus as a whole, there's a lot more upload happening or download.
Download happening.
Yeah. Okay.
In terms of the amount of data moving.
Okay.
Yeah. You pull way more data down than you push data up.
Okay.
Under normal circumstances. Using BitTorrent, it's going to be a lot closer. You'll still pull down faster than you put up, and typically people who use BitTorrent cancel the load after they've gotten there, what's in it for them, that kind of thing. But regardless, once we get to these asynchronous connections, so 56K modem, this used compression to get faster download, but the upload on 56K was still 33.6. And if you've seen a fax machine these days and you hear them beep, they all have 33.6 modems in it. Because the upload is 33.6. That's what they're doing. And when they receive, they might have a 56K modem in there for receiving, but typically, if you don't need compression, don't use compression. So downloading at 33.6 probably is less error prone, would be my guess, because you're not having to do that compression stuff. All right, but the piece we want to get from this slide is just the idea of synchronous versus asynchronous. All right, same upload and download or different upload and download. Typically, when we say different and we're talking about the internet connections, our download's a lot faster than our upload. Okay, but that doesn't, you could have an asynchronous connection with that flipped. That make sense? In fact, if you were running servers and you had to choose, you probably would want that flipped. Because if you're running a server, you're probably not downloading that much, but you're uploading a lot. Make sense? Because that's not somebody using that computer. You have a whole lot of people pulling from that computer because that computer is meant to serve data out. All right. So we got that. So now let's swing back to our computer ports. Let me keep going up to an hour here. We got started a little late. So we mentioned a SATA port, mentioned parallel ports, serial ports. What other ports can you tell me about? USB. What else? Okay, M2. It's pretty new. We'll throw that in there. What else? MSATA? I don't know if I've heard of that one before. It's a newer, like an upgrade to SATA?
It's a big one. They don't use the small one.
Okay, a new SATA port?
Yeah.
Okay.
I don't know.
I'm sure it's faster if they switch port. All right, what else? Who? Oh, RJ45. Yeah, technically yes. Technically yes, that's a port. Let's leave that off. That's. I mean, we're talking old at that point. Okay, what else? That's the RJ45. What about FireWire? Heard of FireWire? What about IDE? IDE cable? These guys? IDE cable. These guys?
Yeah.
Ribbon cables? What about SCSI? Oh, we haven't heard of SCSI? Oh, SCSI was great. Okay, so if we do SCSI, there was a whole bunch of different SCSIs. All right, so we had, so this is like a normal SCSI. Then we had ultra wide SCSI. All sorts of different ports, SCSI ports. So none of you have heard of you've ever heard SCSI before? How many of you have seen that word before? SCSI. Half a person? Interesting. Well, so then I suppose nobody knows what it stands for? Actually, in the day when SCSI was popular, it was for networking jobs, it was a pretty common question to ask, what did SCSI stand for? Yeah, small computer system interface. All right. But again, for us, we don't necessarily care about all these different technologies. We care about which category these technologies fall into. parallel versus serial. Okay, so we're going to create two categories, parallel and serial. Where does SATA stand? Where does SATA go? What does SATA stand for? What does the S in SATA stand for?
Serial?
Serial. Okay, so which category do you think this guy goes in? Probably serial. All right. Which category do you think a parallel port goes in? All right. What category do you think a serial port goes in? Man, so far this is easy, right?
We have a double serial port.
What category is USB going?
Serial. Universal serial.
Universal serial bus?
Bus? Yeah.
Hmm? Is this parallel or serial?
No way.
USB is a parallel technology. Parallel. I honestly don't know about M2, but I can give you about a 95% certainty it is serial. Same thing with MSATA. Firewire.
Parallel?
Who is Firewire's competitor? What two technologies were competing with each other with Firewire?
Oh, was that was with USB, wasn't it?
USB.
So,
So he was the other side, right?
gotcha. Serial. Why did USB do so much better?
Well, we'll kind of talk about that. There was several reasons. IDE. So IDE was used for hard drives. Serial ATA is used for hard drives. IDE came before serial ATA. Think this guy's parallel or serial? Parallel. What about SCSI? Who was SCSI's main competitor? Only one of you had heard of Romana, had you heard of SCSI before? Have you heard of this SCSI? So only Van? So who was SCSI's competitor? SCSI's competitor was IDE. So IDE was parallel, SCSI was a serial technology. Okay? So, parallel ports, serial ports kind of came first. Then USB versus Firewire. And kind of at the same time, we had IDE. Actually, this is probably not fair. We never really had IDE versus SATA. You had IDE versus SCSI, and SCSI was always faster. But SCSI had trouble getting a standard. There was a whole bunch of different versions of SCSI, and IDE ended up becoming the standard. So IDE kind of won there. So a parallel technology was how we hooked our hard drives up, and our CD-ROMs and that kind of stuff up. Then our stuff to connect our hard drives up was replaced by SATA, which is a serial technology. Okay, so just for a moment, just to keep things kind of in our world right now, let's talk about a USB versus Firewire. Now, depending on which version of USB or which version of FireWire we're dealing with, these guys, had theoretical maximum speeds that would either one-up the other one. I think the fastest FireWire ever got was, I want to say 400 megabit per second. I think USB got to 800 megabit per second. Actually, USB 3, I think, is substantially faster than that. And USB-C, which is actually a Thunderbolt port, is way faster than that. But for the sake of this argument, since we're not talking about networking stuff specifically, let's just say that at any point in time, one of them had a faster theoretical speed than the other. Okay, but we can call them similar performance for what we're about to talk about. Okay, so USB was parallel, FireWire was serial. So now today we have a lot of external hard drives, right? And external hard drives come in a couple of flavors. Now it used to be when you bought an external hard drive, most external hard drives you buy today connect to your computer through USB, right? Now, you know how you can go out to Best Buy and you can buy a 1 terabyte Western Digital external hard drive, and there's like 3 versions of it, and they have 3 different prices, and you're like, well, why would I pay $60 more for a 1 terabyte drive when I can get what seems like the same drive for less? What's the difference? There is okay. Well, tell me more about that. What do you mean transferring data? Are we talking about speed? Are we talking about ports? Okay, so you could have a situation where you have a 5400 RPM hard drive in a external versus a 7200 RPM hard drive. So 7200 RPM would be a higher performance drive, and you would get a little more speed out of that. Generally speaking, when you see those different USB external drives, the more expensive the drive, the more connectivity options you have with it. So typically, the budget pleaser is just USB. Now, for a long time, you had ones that were, they would say they were Mac specific, so they would have FireWire. The little bit more expensive one would have USB and FireWire. The even more expensive ones would have USB, FireWire, and, anybody know what the third one would be? Called eSATA. So external SATA port, which is a lot faster. So serial ATA, that's the same thing our internal hard drives are connected with. So now we have our external hard drives potentially connecting to an eSATA port if one was available. Okay? So the more expensive external drives would have multiple connectivity options depending on whether you were hooking it into your laptop through USB, hooking it into your iMac via FireWire, or hooking it into your custom-built desktop computer that happened to have eSATA, or that you happen to snake a SATA cable out one of the back ports and plugged it into that. Either one would work. All right. So when we talk about USB versus FireWire, we're really making that discussion about parallel versus serial. Now, if you go back to what we said an hour ago, is that in here? Is that here? Okay, we said parallel is bursty in speed, whereas serial is more consistent in speed. So, what kinds of applications really need consistent speed? Where is consistent speed important in computing? Real life, real-time applications.
Streaming?
Is it that important?
I guess not, because you could send it a whole bunch.
Yeah, that's the whole point of buffering, right?
Yeah, right.
It's probably, actually, it's kind of a loaded question. You need it to be consistent to a point, right? If it fluctuates somewhat, not a big deal, because you've hopefully buffered enough to kind of handle that, right? But if your speed goes from 100 megabytes per second down to 0.2 bits per second, you're going to run out of your buffer space pretty quick, right? Unless it was running so fast you actually buffered the entire show before your connection slowed down. All right, but in any case, a good example of something that really benefits from consistent speed is rendering stuff. Okay, so if you're talking about video rendering or even image rendering, most graphic design type people, multimedia content creators, they would prefer to have a slower transfer rate that's consistent than a faster transfer rate that's bursty. All right, because they'll have less artifacting in their final product. Okay, so again, that's application specific. Okay, but from our perspective, what we really care about here is how this data is being transferred inside of computers. When is data being sent in parallel versus when is data being sent serially, and why? Why is it okay for one to be sent one way versus another? Make sense? All right, so let's take about a 10, 12-minute break. Walk around, do whatever, and then we'll come back, and I want to talk about the different, well, we'll kind of continue on where we started, and then, I mean, this is all good stuff that's not in the book, so it's good we talked about it, but we'll come back and talk about memory and how it kind of works in general, and then down to the specifics.